All right, welcome to 4-5, Solving Polynomial Equations. Turn your textbook to page 190 and 191. I'm going to do page 191, numbers 1 and 3, and you're going to do page 191, numbers 2 and 4. But before we get started, we have a lot to remember. We're looking for the solutions to polynomial equations, and a refresher, and I want you to write this down in your notes. You'll remember that solutions are the same thing as roots, are the same thing as zeros, and they're the same thing as the x-intercepts. Now in the first half of the chapter we did a lot of tedious mathematics and you guys persevered and did wonderful. And in the second half of the chapter we're kind of putting it all together. So it's really important that you remember that when we're asked to solve something, we're also looking for the x-intercepts, which on our graphing calculators can be called the zeros, and we can also call it the roots if we're talking about factors, which brings up my next point. Think back way, I think what, chapter 2, chapter 3 maybe, and we were asked to solve just a quadratic. So let's say we were asked to solve x squared minus 8x plus 7. First thing we did was we changed f of x to 0, and then we factored. We thought of two numbers that could multiply to 7 and add up to negative 8, and I thought of negative 7 and negative 1. I checked my work by foiling, they worked out. And then when I got the factors to figure out the solutions, what did I do? I just changed the signs. So instead of x minus 7, I have positive 7. And instead of negative 1, I have 1. And then we used our graphing calculators. We sketched it out a little bit better. We had a vertex, we had a y-intercept, we had all that stuff, which is important and we're going to get to later. But if I wanted to get like a quick idea, if I knew that my solutions were 7 and 1, I could sketch the graph out and I could say that at 1 and 7, I'm going to have my x-intercepts, right? Solutions are the same thing as x-intercepts. And I know that this is a positive parabola, so it's going to look something like that. So this is sketching an idea of it, okay? So remember, for solutions, we're finding the x-intercepts. To factor, we get down to here, and then we change the sign to get our x-intercepts or our solutions, okay? All right, so on to 191, number 1. So the directions are to solve the equation, and they give us this wonderful equation, 4x to the fourth minus 40x squared plus 36. Now you'll notice this is a 4, this is a 2, so it is just like our quadratic form. And I'm going to look for my GCF first. So the first thing I'm going to do, as my dog walks out of the way, so I have more space, I'm going to take out a 4, right? So we're going to take out a 4, and we're left over with x to the fourth minus 10x squared plus 9, so equals 0. So I have 4 times the quantity, x to the fourth minus 10x squared plus 9 equals 0. And so I still have my quadratic form rule, and so I can think of two numbers that multiply to 9, but add up to negative 10. So I think 9 and 1 do the trick. But remember, when I factor now, because this is x to the fourth, I have x squareds in front. And I said, what, 9 and 1, and they both have to be negative. All right, but I'm not done there. Of course, it's going to be a trick question. This is a dots problem, and this is a dots problem. So let's keep factoring. X squared minus 9 is x plus 3x minus 3. X squared minus 1 is x plus 1, x minus 1, and I still have an equals 0. All right, so I know that's messy, but 4 times the quantity of x plus 3 times the quantity of x minus 3 times the quantity of x plus 1 times the quantity of x minus 1, and now I'm down to x's, so all I need to do is change the sign. So to solve this, I don't care about the 4. Change the sign here, so that's a negative 3. Let me write that clearer for you. Change the sign, positive 3. Change the sign, negative 1, and change the sign, positive 1. So my solutions to 4x to the fourth minus 40x squared plus 36 are negative 3, positive 3, negative 1, and positive 1. You should pause here, finish writing it down. When you're done with that, try number 2 right now, and I'm going to get ready for number 3. All right, before I start number 3, we talked about this briefly at the beginning of the chapter, and you're going to have to write down some more notes. So we're not only going to solve a polynomial function, we're then going to do a rough sketch. We are not using our graphing calculators yet because we just want an idea of what it looks like. This is also how we check to see if we plugged it in right to our graphing calculator. And since the calculator is not as smart as us, it's how we know that the calculator is giving us reasonable answers. Okay, so I made a little chart for you. I have the leading coefficient, LC, leading coefficient, the degree of the polynomial, and then finally, what does it look like at the ends? You know, like a x squared function, it's either going to both go up or both go down, right? So at the end, it's either going up or it's going down. So if my leading coefficient's a positive number, let's say 3, and my degree is even, let's say x squared, I know that at the end of it, it's going to go up. Both ends are going to go up. However, if it's a leading coefficient with a negative number, like -5, but I still have an even degree, so let's say x squared or x to the 4th, the end behavior is going to both go down. Those are two arrows pointing down. All right, and then finally, if I have a positive leading coefficient, but an odd exponent like 1 or 3 or 5 or so on, then my end behavior doesn't go in the same direction. It goes up to the right, down to the left. Okay, so up to the right, down to the left. But if I have a negative leading coefficient with an odd exponent, it's going to be reversed. It's going to go up to the left and then down to the right. So that's what it's going to look like at the end. So copy down the chart. There is a picture in your book, I think in chapter 4, section 1, if I'm not mistaken, but we're going to talk more about it in class anyway and do some drawings. All right, but we need to know this to get a rough sketch of the polynomials that we're going to solve. Okay, so when you're done with that, I'll be ready for number 3. So it says to find the zeros of the function and then sketch a graph. So the graph's not going to be perfect, but it's going to give us a good idea of what we should be looking for later on when we use our calculator. All right, so f of x equals 3x to the 4th minus 6x squared plus 3. All right, first thing I'm going to do, I realize that I have a greatest common factor. Okay, so I'm going to set this equal to 0, take out my GCF. I'm left with x to the 4th minus 2x squared plus 1. Okay, and I have a quadratic form where this exponent is twice that exponent. So now, well, actually this is a perfect square trinomial, but you could also think of it as two numbers that multiply to 1 but add up to -2. So I have x squared minus 1 and x squared minus 1. Now, I actually do want to write it out this way, just so I don't confuse myself later with the extra squareds, because that does get confusing even for your teacher. I still have two dots problems to go. So I can factor that, and I get x plus 1, x minus 1, x plus 1, x minus 1. And then that's equal to 0. And the 3 doesn't really matter here because we're going to divide it out and it's going to be 3. But so my factors are 3 times the quantity x plus 1, x minus 1, x plus 1, x minus 1. And if I just change the signs to solve, I have a -1 here and here. I'm not going to write it twice though. And I have a +1 as well. So my solutions are -1 and +1. All right, let me hold it closer so you can pause and you can finish copying it down, but remember GCF, factor all the way, you probably have a hidden dots problem, and then you have your two things here. But now we need to sketch a graph. So let me get my next and last whiteboard ready, and we're going to just sketch an idea of the graph. So I'm going to rewrite the question because it's kind of important. There's one piece of information that's in the question that we want to use for our sketch. All right, so let's do a very lame xy plane, and I know that I have an x-intercept at -1 and an x-intercept at 1, so 1, 0, -1, 0. Do you have to label them? Yes, you do. We also know, by the way, that the y-intercept is just 3. Because the y-intercept is what you get when you plug in 0 for x. So you plug in 0 here, goes away. Plug in 0 here, goes away. So we also have a y-intercept at 3. And we want to use this y-intercept to help us figure out the overall picture. So let's look at our chart though. We have a leading coefficient that's positive 3. The degree of the function's even. So our end behavior is going to end up going to the top of the chart. So can I now sketch a graph that ends up reaching towards infinity on both sides, but connects all these points? And the answer is yes. It's actually going to look like a W. So make sure that's curvy, and that's a sketch. We can use our graphing calculator later to get an exact answer, but again, we want to make sure we know what we're looking for so that we know that our calculator is giving us the right response. All right, so all I did to sketch a rough graph is plotted my x-intercepts that I found, plotted the y-intercept, easy to find, and then I used my chart on the end behavior to figure out what's it supposed to look like on the opposite, far left and far right, and there you go. That's a good sketch, okay? This was number 3. You're trying number 4 on page 191. All right, and then when you're done, we'll have another video.